Okay, we're going to start by talking about the faces on this triangular pyramid. Or prism, excuse me. This is a triangular prism. So we want to talk about the number of faces and the number of vertices it has. And then we will use Euler's formula to figure out the number of edges this figure has. So first, let's talk about the faces. It has two bases as triangles, and then it has one rectangle for every side of that base. So that's two bases plus three rectangles is 5 faces, or n plus 2. The number of sides on the polygonal base, which would be 3 plus the two bases themselves. The vertices, I'm going to use like the red marker like I did in class, would be 1, 2, 3, 4, 5, 6. So there are 6 vertices here. Okay, the other way we could figure that out is taking 2 times n. So to figure out the number of edges, we would take the vertices plus the faces minus 2, which would be 6 plus 5 minus 2, which leaves us with 9 edges. So for the triangular prism, we have 5 faces, 6 vertices, and 9 edges. Let's try the next prism on the next slide over. Okay, so first we have to look at the base. If we look at the base, it has 5 sides. So this is a pentagonal prism. Okay, so we skipped the rectangular prism in order of the table, just so you guys know. So if we're talking about a pentagon, then n is equal... Sorry, guys. I messed up because my handwriting is too big. N is equal to 5, okay, if we have a pentagon here. So let's talk faces, vertices, and then we'll use our formula to find our edges. Vertices plus faces minus 2. So the number of faces are the two bases. There's 1, 2, and then each of the rectangles on every side. So there's 1, let's do it this way. There's 1, 2, 3, 4, 5 rectangles. So again, n plus 2, or 7 faces. Then we have, let me get rid of those markings that I made. Then what we have is the number of vertices, which again, I'll go ahead and put them in red to make it really clear how I'm counting them. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 vertices. And we can use our formula to figure out if we take our vertices plus our faces and subtract 2, we learn that there are 15 edges. Okay. On the next slide, we're going to fill in the rest of our table. Remember that to find the faces, we did n plus 2, and to find the vertices, we did 2n. So we really have to identify what is n, and that's based on the character or whatever the base is. So let's start by filling in that column of our table. So we're going to start with the character, so it's going to help us with our n. So when we're looking at something that is triangular, then that has a triangle as the character. Rectangular has a rectangle. Pentagonal has a pentagon. Hexagonal has a hexagon. Octagonal has an octagon. And decagonal has a decagon. Oops. Spell it right. Okay, so we talked about already the triangular prism, and we said it had 5 faces, 6 vertices, and 9 edges. We also calculated it for the pentagon, where we said it had 7 faces, 10 vertices, and 15 edges. So just to make sure we're crystal clear, for the triangle, that meant n was equal to 3. And for the pentagon, that was n is equal to 5. So let's go ahead and fill that in so we can use the equations a little easier. For the rectangle, n is 4. For the hexagon, n is 6. For the octagon, n is 8. And for the decagon, n is 10. So now we can use that information to help us fill in the rest of the chart. So for example, we'll go in order this time. On a rectangle, the number of vertices would be 2n. So that would be 8 vertices. And the number of faces would be n plus 2. So that would be 4 plus 2, or 6. To find the number of edges, we would add the number of vertices and the number of faces and subtract 2. So we would get 12 edges. Let's continue to fill in the rest for our prisms. When we talk about vertices, we talk about it being 2n. So if we're looking at a hexagon as a base, then that would be 2 times 6, or 12. Then we would go to faces. That would be 6 plus 2, or 8. Then, to find our edges, we do our equation. 12 plus 8 minus 2, which gives me 18 edges. 2 more. An octagon for a base of a prism means that we have 2 times 8, or 16 vertices. Then we go to the faces. It would have n plus 2, so that would mean 10 faces. So to calculate the number of edges, we would add the number of vertices plus the number of faces and subtract 2. And there we would get 24. Now to the decagon. 2 times 10 is 20, so there are 20 vertices. 10 plus 2 is 12, so there are 12 faces. 20 plus 12 minus 2 gives me 30. There are 30 edges in the decagonal prism. Okay, on the next couple slides, I have a few pictures of pyramids to help us out. So let's take a look at this. This is a square pyramid. So it has a square or a rectangle as a base. Okay, in this case, a square. So first we're going to talk faces, then vertices, then we'll use our formula to find the number of edges. So let's first look at the number of faces. This is a pyramid, so we can see that it has a base, and then it has it has triangles on every side of that base. So there are 4 triangles plus the base, which means there are 5 total faces. We also know that that's the same number of sides on the base plus 1. Vertices, we're going to use our red pen and we're going to check the work here. We know that we've got a vertex at the top. That's 1, 2, 3, 4, and 5. We've got 5 vertices all together. So again, that was n plus 1. And to find our edges, we can take the number of vertices plus the number of bases and subtract 2, which means, which means we have 8 edges. I almost wrote 7 there for a second. So that's our square pyramid. Okay, let's see what is on the next slide, and then we'll go fill in our chart after 2 examples. All right, count the sides on the base. This is a pentagonal pyramid. So it's a pyramid with a pentagon for a base. So we're going to need to know how many faces, how many vertices, and then we can figure out how many edges it has based on the answers to the first 2 questions. So looking at the faces, we know that it has the base, and then it has 1, 2, 3, 4, 5 triangles surrounding the base. So that is 6 total faces, or n plus 1. Then we can look at the vertices. We know that we have n plus 1 vertices here as well, but let's check. There's 1 at the top, and then 2, 3, 4, 5, 6 all the way around. So we were correct. We have 6 vertices, or n plus 1 again. Now we can add the vertices plus the faces, subtract 2, and we find that we have 10 edges on this pentagonal pyramid. Let's fill in the rest of our chart. Okay, so again, we're going to start with the character. So what is the character in each of these figures? We know that it's the base, right? So this would be a triangle on the triangular pyramid. This would be a square for the rectangular pyramid. This is a pentagon. So we did the square and the pentagon in our examples. Then we would move to a hexagon, an octagon, and finally a decagon. And we can remind ourselves that n is the number of sides on each of the bases. So to remind us, n is 4 for the square and 5 for the pentagon. So that meant there were 5 vertices, 5 faces, and 8 edges on the square. That's what we had found on the previous slide. And then we repeated it for the pentagon. We had 6 vertices, 6 faces, and 10 edges. Okay, so let's go kind of backtrack. We need to fill in the triangle. So we'll fill that in as n equals 3. We know a hexagon is 6, octagon is 8, and decagon is 10. So let's use that to help us fill in the rest of the chart. For the triangle, that would have a triangular pyramid would have 4 vertices, 4 faces, and 4 plus 4 minus 2, or 6 edges. Okay, let's try again. We're down to the hexagonal pyramid. That would have 7 vertices, 7 faces, and then 7 plus 7 minus 2, which is 12 edges. 2 more to go. The octagon has 9 vertices, 9 faces, and then 9 plus 9 minus 2, or 16 edges. And then finally, we have the decagonal pyramid, which has 11 vertices, 11 faces, and 11 plus 11 minus 2, or 20 edges. And our table is complete. Thanks for staying with me.